Hello friends. So there is one more example in which we are using heuristic search technique building a maze solver. Now what is maze? Let's use the A star algorithm to solve a maze. Now this is a new algorithm which we are using. So see, this is your maze and you have to solve that maze. And for solving that maze we are using A star algorithm, which is basically using heuristic search technique in that. So here see the hash symbol indicate obstacles. Now see, these are your obstacles. Hash symbols are representing your obstacles in that maze, and the symbol O represents the starting point. Now see, this is your O is representing your starting point. You are here, and the symbol X represents the goal, and you have to reach there. So basically you have to tell the path how will you reach to that X in that maze, and these are your obstacles. So our goal is to find the shortest path from the start to the end point. Now what is our goal? Our goal is to find the shortest path to reach that X position. And we are using here A star algorithm in which we are using heuristic search technique. So this is our example in which we have to find out the minimum shortest optimal path for reaching our target. And so that's your maze. And now let's see how we can see this in Python. And it is this solution is a variant of the solution provided in the simple AI library. So this is the variant of the solution. This is different solution. Okay, so let's see this maze problem in Python. Okay, now first step is you have to import module, and here we are using the module simple AI for heuristic search. Okay, so you have to first install that module and then you can import that module. So since we are using A star algorithm, that algorithm can be imported using that module, that is your simple AI.search. Okay, next we have created a class that is your maze solver, which is containing the methods to solve the maze. First we are defining an initializing method, that is we are initializing the class. It's just like a constructor. We have declaring here board and goal. Okay, next this is your we are initializing them in the form of O and X. So we can say that your starting point is O and your final goal is your X. So we have to reach that position from that position, and we are initializing them as your initial and goal variable. Okay, next we are defining the method that takes action to arrive at the solution. So this is your method that is taking action, and next we are updating the state based on the action. So xy is your state, yani it's your current state at where you are standing, and if action.count is up, then y will be decremented by 1. If action.count is down, then y will be incremented by 1. If action.count is left, then x will be decremented by 1, and if action is right, then x will be incremented by 1, and your new state will be final x and y. So we are updating our current state based on the action in this method. Next is goal function is to check if we have reached the goal. So next we are computing the cost of taking an action, and for that we are using the cost function. In this we are providing this current state, your action, and your state 2. So finally it is providing the cost. Next we are defining heuristic function, which is very important here. In on that function our search is depending. So heuristic that we use to arrive at the solution. And here we are declaring xy as your current state and gx gy as your goal, final goal position. And see, this is your we are using here Euclidean distance for calculating heuristic search. Okay, next this is your main function. So first we are initializing our map. Now see, this is your puzzle. Next we are converting this map to a list. Okay, so we have used split function for that. Next we are defining the cost of moving around the map. So your coast regular is 1.0 and your coast diagonal is 1.7. Now what is regular and what is diagonal here? So if you are moving up, down, left and right, then it will be your coast regular. And if you are moving up left, up right, down right, then it will be your coast diagonal. So in that case, 1.7 will be considered as coast, and in that case, 1.0 will be considered as coast. Next, we are creating our maze solver object, and for that, we are using this maze solver which we have created in the form of a class, and we are providing as an argument our map, which is in the form of list. Next, we are running our solver, and for that, we are using a star function. So this is your a star function, and finally it is giving output in the result. Next, we're extracting the path from that result, and then finally we are printing the result. For that, our initial will be printed in the form of O, our goal will be printed in the form of X, and your path will be printed in the form of dot. Okay, and finally it will be your end. Okay, so let's run this program. Now see, this is your puzzle map which you have provided as an input, and this is your output. In this, see, in this output, this is your O is your initial point, X is your goal, you have to reach there, and these dots are representing your path which we have to follow to reach our destination. So by applying that heuristic function on that maze, or you can say this maze puzzle, we have solved this maze and we have find the optimal path for reaching the destination, or you can say target. So in this way you can solve any maze using any heuristic function. By applying any heuristic function, you can use any function of your own choice and can implement. So let's do it. Thank you.